Okay, so FE. Ooh. Okay, so first of all, probably -1, right? Is a solution. Yeah, I don't know what source this is. I'll just look it up at some point. But yeah, so if I set a 0, so P of x0 gives surjective, and if I want to get injective, I have to how do I get injective? So if FA equals FB, I need a Y such that 2. Yeah. Wait, 0 should work, right? Hang on. Lagging. Yeah. P of x0 gives surjective and bijective because it gives f of x, f0 is a function is minus x. So if f of a equals f of b, then great. Okay. Now, are there any other solutions other than t minus 1? Did I miss any? Is like 1 minus t a solution? No, it's not. The slope of any solution should satisfy k squared equals 1. No, wait, where is it? K cubed equals 1. Right, so k equals 1. What if f0 equals 0? That doesn't matter. Like, in fact, I think this should show f of 0 is not 0. If f of a equals f of b, then minus a equals minus b, full stop. I'm not dividing by 0 here. Is 1 minus x t a solution? No, it's not, right? You get like a minus x1 on the left. Yeah, okay, so I'm not crazy. Okay, anyways, continuing on. Right, so also I can get thing equal to 0. So like for example, well, f of 0 squared is equal to 0, but there are other pairs of numbers for which, like, when is xy minus x minus y equal to 0? Either one of the numbers is 1. As well. So, and also, p of 1 x comma 1 gives f of x f1 is equal to minus 1. Oh, freak, that's not 0. What? Sorry, I'm silly. Ignore that. This is something different though. Yeah, but this will imply f of 1 is identically 0 because otherwise you have a bijection. And hence f of 1 equals 0 and f of 0 equals minus 1. Okay, so this equation doesn't do anything more. Well, actually, if f of 0 is minus 1, now f of minus f of x is equal to x. So that's fine. Okay, so actually, anyways, if the function is linear, it is certainly t minus 1 now. So cool. I'm not missing any linear solutions. Cool. Yeah, it's almost involution. But like, I feel like I know. Like f of 1 is equal to 0, so we can get statements like f of x, f of y is equal to 0 if and only if x, y. That's something we already know. But fx something like this is true. Like, because I know this f of 1 is 0, so this holds. It's not that good. If you choose y equals f of y equals okay. So I choose y so f of y equals 1 over fx. Oh, I think we did almost the same thing. Wait, yeah, this is the same thing. Okay, yeah, I do like. Let's do a triple thing though. So f of minus f of x equals f of x. Wait, how does that? No, that doesn't do anything. Oh, actually no, this is fine. So I have, wait, this is weird. So you have f of minus f is the f. And since f is surjective, replacing should be, oh frick, did I miss it? Minus x? Frick, you're right, okay. Okay, so then never mind, this is not true. Yeah, so minus f is an evolution, so in some sense maybe I want to work with the function g equals negative f instead. Then the equation is like, it's almost the same except it's just you get some g stuff. Why doesn't FFF work? Well, I mean, there's a minus sign, but we can, I guess there's no reason not to. It's just like g of x equals minus f of x. So now we have, g is an involution, which satisfies g of x, g of y equals x plus y minus xy. And now that you put it that way, I am almost compelled to, you know, or equivalently, g of xy equals g of x plus g of y minus g of x, g of y. Why doesn't Otis Formulas have USMO 2023? I might have stuffed use of mode 3 and like super in T. Maybe it's better in formulas. Wait, okay, something happened, but I missed what. This equation is true, and then how do we... How do I get this last form? Well, G is an involution, so you replace... Yeah, because G is involution, you can replace x with G of x, and... Okay, take G of both sides. Oh, that's pretty good. Okay, you know what? You know what? Yeah, we're gonna shift. We should shift by 1. It's asking for it at this point. So this is true if and only if G of x minus 1, G of y minus 1 is equal to G of x. Yeah, I feel like we're getting... How does the stuff go inside? Okay, let's take G of both sides. I'll follow what the suggested. So we go here, and then the left-hand side by hypothesis xy minus xy. And then you do the same thing. So I again replace x and y with the thingies, and now I have this. And so... Well, which thing do I want to get rid of? I want to get rid of G of x. Wait, what the heck? What did I do? That's not what's supposed to happen. This is minus. Wait, something's weird. What did I do? That's not correct. Take G of both sides. This is x plus y minus xy. And that. And then I again replace the variables. And I get G of x plus G of y. No. Something's wrong. These two are not equal in general. Okay, so the way you debug this is you check when the functional equation stops having... Oh wait, yeah, G of this makes no sense. I don't know how I got that. G of xy. G of x plus G of y minus G of... So I keep replacing the variables over and over. That's also not correct though. So g of xy is g of x plus g of y. No, what am I talking about? This is just xy. Okay, I think I at least fixed the bug. Alright, and now I do the replacement. So g of x, g of y is like... Okay, I finally got to what Twitch said a while ago. Amazing! We made it! Arithmetic is too hard. Okay, what do I do now? Can I take g of both sides of this? I feel like that's pretty good, right? So I take g of both sides of this, and I will get... Wait! Oh! No, well, wait, I just went in a circle, right? Like, this is just what happens if I take g of both sides of here. How did I take so long to get to this? What? Okay, so I'm supposed to shift by 1. Okay, so... Okay. That's not correct. I want 1 minus, right? Okay, so here we are, and 1 minus g is a multiplicative function. But it's also an involutive thing. Okay, so what do we know? We know 1 minus g is multiplicative. And we know that g is involution. Okay, sure. What is the multiplicative Cauchy solution? Nothing good. Like if you take a log, if you do like a log transform, it's equivalent to Kochi. Like, just pretend you took like log base 10 or something. Can someone fill me in on what happened? We got to 1 minus g is multiplicative. I haven't done anything much else. I'm like trying to like be gentle, but at some point I need to just like throw the hammer. Something about this bugs me. I feel like there's not enough conditions or something. I can't quite see the details. However, it's like 1 minus g is multiplicative and g is an involution. That doesn't seem like enough constraints. Like okay, I am gonna rewrite this. So is it 1 minus? Did I get it wrong? From here. Thank you, Brian ZGK, for the chair. No, I think 1 minus g is correct. I feel like there's not enough conditions. Like, let's let g equals 1 plus h. 1 minus h. Where h is multiplicative. So then what does it mean that g is an involution? It's like 1 minus h, 1 minus h, x. Does that not happen or something? Yeah, so I'm looking for all multiplicative functions that satisfy this equation, which I will go ahead and just rewrite as h of 1 minus h x equals okay, actually that shouldn't be, yeah, I should be able to do it because I have addition, right? Or something. So let's just take, like, I feel like I should just hit it with a crowbar. Just try to finish from here. because addition and multiplication don't mix, so I should be able to do almost anything if I haven't messed up. So on the one hand, this is 1 minus xy. On the other hand, it's also equal to h of 1 minus h inverse of hx hy. What am I writing? Alright, can I mix the linear in circle? How's this problem taking so long? How long has it been? Okay, now I'm very confused. No, okay. Plan B, plan B. Isn't h also multiplicative? Yeah, h is multiplicative. Yeah. So multiply these together and I'll get a thing. This is also equal to h inverse of hx plus hy plus h of xy. You can get a mute. Yes, you can get a mute. Here, have a mute. You're welcome. Okay, so what was I trying to do with this? Okay, cool. I had a thing, right? And then, this might not just be the original. This might just be the original equation. Which, if so, is not good for me. It's like okay, I got to this. Okay, so I try to force the multiplicative statement to say something. I'm not sure that did very much. Actually, it's not. It's not awful, but I feel like that just went in a circle. Yeah, I had this already from the original G equation. I don't hate it, but Effie. What do I do? Wait, Evan, what's going on right now? I'm trying to do an FE. It's not going very well. Do I even know H is multiplicative or bijective actually? I know it's like I want to find. Like, I want all functions for which 1 minus g is multiplicative and g is an involution. It is this, right? Like this. If g is such a function, then 1 minus f sorry. Yeah. Yeah. So why am I so like I have it down to something that's I want. All right. I'm gonna hide all this for now. Works with for multiplicative, right? Oh, frick, is there a non-trivial solution I missed? I don't think there should be a well, because this contest appeared on problem appeared on a contest, I would be surprised if there was a pathological solution, because I know the set of multiplicative functions. Is H an involution? I that would be nice. No. So equivalently, find all multiplicative H obeying H1 minus H minus X. H equals what? H over 1 minus X gives an involution. Thank you, FVDQYXM, for the follow. Plug 1 over X into the equation I have. Yeah, okay, 1 minus H. Okay, then what? How do we get evolution from this? Is it, do I say this is like n minus h of x minus 1 over h of x? Yeah, multiplicative is fine. So h of 1 is equal to 1 because g of 1 was equal to 0. So this is true. And the numerator is h of minus 1 times 1 minus x. That's such a weird manipulation. Alright, we know the... Do we know h of minus 1? I mean, h of minus 1 is either 1 plus 1 or minus 1. Did I have enough information to get it? H of minus, I agree, but H is not, we don't know it's bijective yet, right? Oh, but I guess G is bijective, okay. Yeah, okay, fine. Yeah. Yeah, so since G bijective, H automatically bijective. So H of minus 1 is equal to minus 1. So this gives H is itself an involution. That's really good actually. Okay, great. So we're in business now because now I can substitute. And now h of 1 minus x equals 1 minus h of x. So h commutes with this 1 minus thing.
Y'all think, but I think that's pretty.
Okay, so that puts us in really good shape. I've managed to get rid of the annoying conditions. So, oh, player is NPRIS compliant. So I think this should imply that we are okay. So, it's like a multiplicative, but it commutes with +1. So, for example, h is now determined on rationals. Yeah, multiplicative is pathological. How do we get h of x equals x? It's this part here. Yeah, I was very surprised that it worked, but I'll display it because this is actually the most important bit. Like, it's how we reduce it to something that looks reasonable. Because, like, 1 minus h being bijective is like not a particularly, or involution is not as good as h being an involution. Yeah, h should be determined on rationals now. Imagine being a multiplicative involution. Well, I mean, if you're a multiplicative involution, there's definitely pathological solutions to that. Like, for the same reason that the additive one has pathological solutions. But with the extra addition, it should be fine. It should be fine. How do I check it? I mean, h of x squared plus 2x plus 1 is equal to h of x plus 1 squared equals h of x squared No, that's not good enough. Ah, come on. I think algebraic numbers. Put h x over y into the one periodic statement. Wait, what? I think you can get all algebraic numbers. I agree. H of x to the q equals h of x. Yeah. Make the polynomial by Horner's rule. Okay, so we're trying to get additive. Oh, yeah, okay, I see. Wait. No, what? Where do you get that? The frick? That's not true. Okay, well, I might have to do a size argument. So for every positive number, h of x squared is non-negative. So let's say let alpha be any positive real number. The thing you said, how did... Okay, Vidula, what? Please explain the thing you wrote, because I don't understand it. Like, you claim that you had this equation. I don't see where you're getting it. Solve h of x squared equals h of x squared. Plug x over y into the last red thing. Into here. The RMM problem. Yeah, that's what I was gonna do, something like that. But so someone is telling me they can do it without size, so I want to see. You plug x over y. I don't know where you're getting the extra h from. You're plugging in h of x over y. Oh. The heck? Does this actually work? Okay. No, but if you plug in h over x over y, this should be x over y, right? Okay, so it's x over y on the right hand side. And now use multiplicative. Okay. So I'm gonna multiply both sides by h of y, and this means h of x plus h of y is equal to, or by y, so it's like x plus y. Oh, wait. How does that work? Now I'm really confused, because I feel like I had good heuristics to believe that this shouldn't be possible. But the number of h's is working out. Where do we get h? It's plug x equals h of x over y into a previous equation. So an involutive satisfies the +1 condition. What the heck? I still don't believe it. Okay, I guess it works. Does this require h of y equals y? I don't think it does. It still bugs me though. Yeah, I feel like this shouldn't work, but it seems to work. Like here, what happens is I'm multiplying both sides by h of y. Yeah, so now h is both additive and multiplicative, which is fine. How do you feel about this problem? I'm really confused. How did that work? That's not supposed to work. What? Okay. You're just generalizing the h of x plus 1. Yeah, but I didn't think it should be generalizable. I guess this is a little, I think there's more layers here than you need. Like you don't need to plug, I think that plugs, it's like plug x equals a over b into previous equation and multiply both sides by h of b, and then you get like h of b, h of a over b plus 1. Yeah. Yeah, I think it got confusing because we like did two substitutions that canceled each other out. You need involution first. Yeah, you get involution first, but from once you're there, you also have this. So then we're here, and this left-hand side happens to equal h of a plus b. Yeah. Heard of beating PVZ without symmetry? Protoss versus Zerg or what? Yeah, this feels a little better. I guess it's supposed to work. Plants versus zombies? The heck? Alright. Did people say this was on like Duke's MO? No, I've never played Plants vs Zombies. Yeah, I mean, that's what's supposed to happen when you like solve problems. Like you're not supposed to get the best solution in one shot. What usually happens, you stumble around and you eventually find a root, and then once you have the root, you think a bit more and try to optimize it.